better and not have to screw around with it for 10 minutes first. Okay, I'm done. Yes. So for those who don't know me, I'm Darcy, general purpose Gluster hacker, I guess. Probably less than better. So we're going to be talking about what is variously called Gluster Next, Gluster Forum, etc. Joe was just talking about some of them. Now, before I start diving into details of what the specific features are going to be, I'd like to sort of set a little bit of context for what we're really trying to achieve with 4.0. So it's 4.0, it's not 3.8, it's not 3.9, it's not 3.7.1. I mean, it's supposed to be a major release. It's supposed to be more ambitious. It's supposed to be more different. Looking back, the 3.x series has lasted us several years. Even if you start from 3.1, which sort of, kind of, should have really been 4.0, because it was very different from 3.0. But no matter how you look at it, it was there for a while. So we need to think about it not in terms of how we would normally plan a release. It's like, oh, here's a feature, here's a feature, here's a feature. And this is going to be a general uplift for the entire code base. It's going to be a pretty significant piece of work. And the main thing is that we can't think about what the target system is going to look like just a year from now. And as much as it scares me, we have to think about what our system is going to look like in 2021. And if you compare what a system today looks like compared to one in 2010, there's been a lot of change. And back then, solid state disks were not anywhere near the presence that they are today. Networking was not anywhere near where it was today. Servers were not anywhere near where they are today. It's going to get annoying. I jinxed myself, apparently.
You're back.
Okay. Well, it may be an issue that I don't actually have it plugged in. Sometimes the laptops behave differently. It's a brand new laptop because Rick, my boss, gave me a ton of crap for carrying it back around. So I am actually running Fedora on this thing. I haven't learned all of the ins and outs of handling multiple monitors that well. So anyway, so let's take a look in our crystal ball. I have to put one stupid graphic in here. There's one per presentation. So anybody got any thoughts on what systems are going to look like in 2021? Anybody else?
Hardwired into people's brains.
Okay. I'm not sure exactly what we're going to do with that. Hopefully we're not going to crash it and take it down.
Yeah.
So here's a couple of ideas. One is no counts are going to get high, because they always do. One of the places we can look for sort of guidance here is what's happened, say, to the Hadoop clusters. They've gotten bigger and bigger and bigger. A few years ago, there weren't too many places, maybe Yahoo running in the high hundreds. Now that's fairly routine. We're going to see the same thing. Right now, we're anybody know what our largest installation is right now?
I think
I've heard someone has a couple hundred.
yeah, I think Facebook has one such cluster, and we do have a few search engine companies in China that have a larger count in terms of number of nodes. So
Right.
maybe about close to 300 or beyond.
So what's on the leading edge now
Well, we know
in 2021 is going to be small.
runs against it.
There's going to be a lot of clusters in that range. And one of the things that's going to drive this is the higher density computer infrastructures that are coming along. Open compute, the ARM servers, maybe. How many years have we been waiting for ARM servers to take over the world? Been a few. My last company actually was kind of in that space, so if you detect a note of frustration, that's why. You don't tend to get too much of the hot spotting and concentration of traffic. You start getting up to 2, 3, 500 node clusters, it's totally going to kill us. So that's the direction we need to look at. And then we need to deal with heterogeneous hardware. It's not just heterogeneous across the entire space of what's out there in the industry. It's going to be heterogeneous in terms of what exists within our cluster. We're seeing more and more of different types of storage being deployed. We're seeing more and more of different types of networks being deployed. So there's a different network on the back end than there is on the front end. By 2021, we're probably going to be seeing multiple network speeds on the front end and multiple network speeds on the back end as well. And they're all going to be segmented. They're going to be used for different purposes. So for example, we might have one that we use for rebalancing that's separate from the others. Things like that. And then this little bullet down at the bottom, competitive pressure. That's just a sort of a reminder that we don't even know what new things are going to come along in 5 years. Somebody's going to come along and they're going to throw a curveball at us. We're going to have some new technology that's very disruptive. We're going to have new competitors who are doing something disruptive that we need to catch up to. So these are all things that are going to drive our evolution for the next 5 years. So, what are the problems particularly with scale? I mean, that's our number one challenge. It's not our only challenge, but it's our number one challenge. Obviously, performance. We have places in the code right now where we're just not built for that kind of a scale. We have too many messages. Now, the problem with having broadcast type operations, like we do in GlusterD for configuration changes, like we do in DHT as the fallback for lookups, is not just that there's too many messages. It's not just that it affects performance, that it's consuming a lot of hardware. One of the problems is that you're always going to have to wait for whoever's the slowest. So if you have one node that for whatever reason is being slow, you're going to wait for it. Some guys at Google actually produced an article called "The Tail at Scale," which is about this phenomenon. That when you get up into hundreds of nodes, there's always a laggard. And also, there's always probably somebody who's dead. And there are actually two different conditions, but there are two things that you can count on at that kind of a scale. So we need to be able to deal with that. We need to be able to say, we're not going to wait for 200 nodes to weigh in on every single thing that we do. We're not going to wait for them all to be present when we make some sort of a change. We're going to have more of a continuous operation, lightweight operation kind of model. Consistency is a related type of issue. A lot of that comes back to the fact that when you're exchanging too many messages, you're over-coordinating, is really the kind of thing we're talking about. It's hard to maintain consistency when that many nodes in the face of failures without affecting performance. So you can think of it as a triangle. You've got consistency, you've got resistance to failures, and you've got performance. Pick two. That's a hard world to be in. It's kind of the world we have to be in. We have to be able to find ways, and fortunately there are known ways in many cases to walk that tightrope. The other thing is operator friendliness. Now, we've gotten a lot better. One of the things that consistently bugs the hell out of me when I follow mentions of Gluster on Twitter and elsewhere is people saying, "Oh, Gluster is so hard to set up and debug and deal with." I was like, try any of the others? I mean, really? We do pretty darn well in that, but it's the nature of the beast. It's the nature of the kind of thing that we do that's difficult. So there's always going to be more that we can do. One area of that is more autonomous, self-directed, independent operation. We've certainly gotten better. Used to be, what did we have to do for self-heal? The user had to do a crawl into the entire file system. That was, people didn't like that very much. didn't like it because it was inconvenient. They didn't like it because it was slow. They didn't like it because it completely tanked performance. So now we have all sorts of new techniques that we use to make cell feel more automatic, to make it faster, to make it more efficient. We need to keep doing that. We need that to extend that. We're doing that with rebalancing. We need to extend that to even performance optimizations, routing around hotspots. Some node is getting overloaded. We figure out how we split the responsibilities that it currently has and offload it. Now, this is not a kind of nice to have. This is not a, well, you know, maybe it would be kind of sort of cool. It's when we're dealing with this scale and this frequency of such problems occurring, we can't be bugging humans to go fix them for us every time they happen. We have to be able to take some responsibility ourselves to do that. That means that we need the infrastructure to know when these things are happening, to evaluate what the correct solution is, and then to go implement it. So there's a whole world of possibilities there for us to be more self-tuning and self-operating. Another part of being operator friendly is nobody is going to want to do a Gluster volume info and see a 2,000 brick listing. That doesn't help them in any way. And we're going to have something like that. I mean, we're going to have a lot of nodes. Each of those nodes might have multiple actual bricks as the user has seen them. We might actually, for reasons I'll get into in a minute, we might actually be splitting those further so that what the user gave to us as one brick is actually split into multiple pieces that fulfill multiple roles. So we are going to have thousands. We can't just dump that on. And saying, oh, you should write a script to filter the output isn't any better. I mean, that we actually have to have a model built into our own software of these things being hierarchical, being able to show information at multiple levels. So if you want to know what's going on in this rack, for example, you can do that directly from the CLI without having to script around it. So, as I said earlier, one of our main problems is over-coordination. The idea that we're touching too many nodes, we're requiring consensus from too many nodes, we're requiring even mere acknowledgement from too many nodes on an operation. So one of the key design principles for every successful distributed system out there is to get a tight rein on how many nodes have to be involved in each action, decision, operation. We actually do this in some areas. DHT, the whole way that consistent hashing works, why it works, why every distributed file system and distributed database nowadays is doing some kind of consistent hashing, is that it addresses this exact problem. You don't have some central directory that becomes a bottleneck at a single point of failure. And you can actually distribute the work among a bunch of nodes and touch very few of them for each operation. So that's a real key design principle. We're applying it in Gluster D version 2. Maybe I'm getting a little bit ambitious with the naming there. So KP is going to be talking about that some more. We're going to be doing that with DHT. Again, more operations are going to be limited in the scope of how many nodes they have to talk to. We're not going to have this global directory issue that we have now. Sean was actually supposed to give that talk, but he can't be here, so I'm going to do my best to fill in for him, I think, at 1:30. So you can see me again, yay. And client-side caching. Now, client-side caching is a double-edged sword. In some ways, it offloads the servers, it allows clients to operate independently. So this is a performance improvement, and it's also a simplicity improvement in those cases. But if you just cache naively and you don't think about consistency, well, then that's just not acceptable. You need it to be consistent. You need caches to be validated, updated. You need locks to be broken, things like that. So there's a certain amount of complexity that we pay up front to do client-side caching. Hopefully, once we pay that upfront cost, the ongoing cost, the cost because a lot of operations just won't even cross the network from the client. You've got a lock, or you've got something in cache, you know the lock hasn't been broken, you know the cache hasn't been invalidated, you don't need to talk to anybody. You go do your thing. And again, with 1,000 nodes, that's going to be pretty important. That's, you know, a couple hundred nodes at any given time doing their own thing instead of going and commenting on the servers and making them known back. So, next point, or next theme, as I put it, is designing for heterogeneity. So, again, we're going to have a ton of different kinds of storage. We're going to have good old-fashioned spinning disks, as we know and loathe them already. On the slow side, we're going to have shingle disks, which offer huge capacity, but some interesting challenges, both in terms of performance and in terms of complexity. On the faster side, flash is just going to become ever more prevalent, ever better. It's going to be coming to us in different flavors. It's not just going to be in the form of an SSD. Server-side flash is already becoming common. Memory bus flash is becoming more common. And then there's the other technologies, which are still kind of racing to displace flash. So you've got resistive RAM and magneto-resistive RAM, and just half a dozen different flavors. And they all actually have interesting characteristics. So for example, see if I can get this the right way around. Flash is actually pretty fast and pretty energy efficient for reading, kind of sucks for writing. Phase change memory, by contrast, is the exact opposite. So we need to deal with that kind of thing. We need to be able to say, this is a read-optimized device, this is a write-optimized device. You know, they have varying levels of being friendly towards sequential versus random access. They have block size considerations. Flash, by now, most people have figured out that there's actually a write block size and an erase block size, both of which you have to be aware of to truly optimize for Flash. And all of these technologies have these little gotchas. I'm trying to remember, there's a fatigue syndrome that affects resistive RAM, for example. So you need to be able to recognize that and work around it and so forth. So one of the ways that we intend to deal with this is what I call data classification. So far, that has mostly been applicable to tiering. In the future, it's going to be much more complicated because we have a bunch of problems that share some fundamental characteristics, but they also have slight differences. So tiering is one. Location-aware placement is another. So placing things in a particular rack, or placing them deliberately across racks, across switches, on the same switch. All of these things you know, need a very similar infrastructure. You're taking some data that has certain attributes, you're taking some storage locations that have certain attributes, and you're performing some sort of a matching function to figure out where that data should go. Security-aware placement, multi-tenancy. Those are other areas that have exactly the same features, a matching function between the characteristics of the storage and the characteristics of the data. So as we move towards 4.0, this is going to become much more generic than it is currently. We're going to be using it for a whole bunch of purposes. Very closely related to that is that we're going to change the way that we think about bricks. We sort of have the too few bricks problem, that if we're trying to create a complex hierarchy, you can end up with a pool that has too few bricks to be effective. That it's not distributed enough across enough nodes or across devices. So what we're going to be doing is actually splitting the brick that the user gives us. I haven't come up with good terminology for this, but let's call that a U brick. We're going to split that up into multiple S bricks, and we might use one of those as part of an erasure coding set at one point in the data classification hierarchy, and then we use a different part of that same brick as the user sees it as part of a replica set in a different part of the hierarchy. If we're doing multi-tenancy, we're going to be splitting things all sorts of different ways because we're just not going to have as many physical devices as we have tenants, potentially. We have to split. There's no other way around it. Jersey side of the Hudson River, and they want to be able to replicate across those. Now, we're going to hear some about some different technologies that allow people to do that. But again, it's a heterogeneous network is what it comes down to. Is that the network between those data centers has different latency characteristics than the network within each one. So having more replication options can only be a good thing in that kind of environment. Improved network products, split networks, multiple front-end networks, multiple back-end networks, and of course that global flow control. Those of you who've been following the mailing list have probably seen me bring that up several times already in different contexts because it keeps coming up. BitRot has hit this, Rebalance has hit this. Basically anything that's moving a lot of data is starting to hit this, and they're hitting it individually. When you take the combination of all of these, when you have 6 different things happening within the system, you have this enormous potential for them to crowd each other out and for them to crowd users out. So we need to not just sort of apply ad hoc solutions for each of these individual cases where we have this problem. We need to start looking at technologies for a global solution across the entire system to make sure that network bandwidth and resources are allocated the way that we want them to be, or even better, the way the user wants them to be across these different activities. Because user 1 might actually want their rebalance or other internal operation to go very quickly, even if that means disrupting user I/O for a period. User 2 might say, I want that to run strictly in the background. I don't want user I/O to be affected. So we have to give them some knobs to tune that as well. And we can only do that if we have a coherent global model. If it's 3 different knobs for each 8 different subsystems, that's not doing our users any favors. There's no way that we're going to be able to tune that effectively. We're sort of moving down from the biggest pieces to the smaller pieces. Another focus area, hopefully this time, is going to be small file performance. How many of you have actually had to field complaints from users about small file performance? Oh, come on. Only that many? No, seriously. I mean, this is like what every small files, large directories. This is what we always get beaten up on. And again, tried any of the others? It's one of my favorite lines. So we're looking at several approaches to this. One is a cache on the server side for stat and exabyte arrays. In fact, my personal preference, which I don't think I've gotten people to agree to yet, but I'll just keep being annoying until I do, is let's just not use exabytes at all. Let's pretend that we use exabytes. Let's make them look like exabytes, but actually siphon them off into the database somewhere. Because file system, exabyte handling is it's not what we might wish. The SF guys had some very juicy commentary on this because they did the same thing. Yes?
Well, we're already apparently using SQLite for some stuff, so would that work in with that?
Something like that, yes.
Yeah.
Please, Lord, not SQLite, but something in that vein.
What's kind of interesting is Seth is doing away with their X-adders and putting them into a database. And one of the reasons they're doing that is because they have a lot of trouble with manipulating X-adders and transactions. And I just know transactions is much easier in a database.
You know what size items they're allocating to deal with that? Okay, now we allocate what I thought were some pretty big items at 512 or 1024. They actually allocate 64K items. So, I mean, small file performance with 64, never mind. Clearly not their focus. Hey, Joe. That's one area that we're looking at is just sort of getting the local file system out of the way a little bit more that way. Sage Wild is actually working on what they call Gluster,
different degrees of success. The Swift guys were using SQLite, they encountered bit of problems there, so I think there's hope for us to learn from a lot more projects in the overall ecosystem. Pick a choice, which hopefully will scale better for guys.
Yeah, I mean, in some of these areas, they've been dealing with these same issues a little bit longer and in a little bit greater depth than we have.
Yeah.
So, I mean, given that there are siblings, we'd be totally foolish not to make them do all the work. So another aspect of small file performance is composite operations. Ben England is really big on this idea. Now, at one level, composite operations might just be new operations that we treat essentially as new operations that are more complex than the ones we have. We have no reasonable way to expose these through something like a Fuse interface. We absolutely have a way to express them through something like GFAPI. And we should. Because in a lot of cases there's very direct benefits that are various integrations with Ganesha, with Samba, with just about anything else. They are actually prepared to use more complex operations if they're available. So if we get those in the GFAPI, they can use them even if the native file system users can't. That's still better. At the other end of the scale, I'm a little bit uncomfortable going to this level of complexity, but if we had a generalized composite operation mechanism, such that you could create a transaction and perform arbitrary operations within that transaction and have transactional semantics if they all succeed or they all fail, even if they're contingent on one another. Now that would be really, really cool. Again, learning from the Ceph guys, that's really, really hard. So I'm not sure if we'll actually do that kind of composite operations. We're still looking into that. Another area near and dear to my heart is technical debt reduction. Who thinks that we have a really spiffy, new, clean code base?
Okay, maybe not.
Well, pretty much nobody. Sorry, I didn't mean to call you nobody. But yeah, I mean, it's 500,000 lines of code last I looked. Probably more. Thank you, Tom. It's evolved rather than been designed in some cases. It's kind of showing, I mean, this is not a knock on the people working on it. It's what happens to big old code bases. You can't just sort of wish away the technical debt that happens. You have to aggressively, explicitly start going after it. And I'm hoping that as part of the 4.0 project, that's one of the things we'll be able to do. So code generation is actually one of the easier things we can do. We have a lot of duplication of code. We have a lot of repetitive boilerplate. I see Becky nodding his head. I mean, that change log code, I mean, that's pretty tiresome to run, isn't it? There's a new file, oh great, we'll figure out which file is closest, we'll copy it, we'll modify a couple of fields. We do this for default functions, sync-ups, GFAPI, stubs. All of these are actually, for a given file, they're operating on the same information, but if you do them by hand, it's time-consuming, it's tedious, and it's error-prone. I've actually done a little bit of work with code generation. And in the process, I found several places where we were, in fact, inconsistent across stubs and default functions and so forth. Where one of them had the arguments in a different order or was missing one. There's an effort recently to get all of the GFAPI operations to accept Xdata. So I think we can actually reduce a pretty noticeable piece of technical debt just by that. GlusterD plugins, GlusterD team is going absolutely nuts because everybody who implements any feature just sticks their fingers with the GlusterD pie and goes like this. and the GlusterD team themselves have no idea what those guys just did. And each time that happens, it makes it a little bit more complicated for the next person. So at this point, we've added like the last 8 features, and know I can't add anything new to that code without having to go through like 20 regression tests before I can get to the past, because, oops, I forgot to make sure that the quota T vol file got updated properly. So if we can do not just Bulkhead, but other parts as well, some of the transaction engine, in a modular fashion, so when you add a feature, you add a plugin that's completely independent from the core GlusterB code, that will keep everything much cleaner and more maintainable. Component rewrites I almost didn't put there. I'll just go over quickly. New languages, even more dangerous. There are certainly pieces of the code that would be better done in a language other than C. Thank you. I think that's probably not very controversial at this point. Now we don't want to just go mass rewriting everything in Go or whatever language we choose, but especially some of the background activities that are more synchronous, the rebalancing, the self-heal, reconciliation in NSR, migrations, some of that introspection I talked about for self-tuning. Some of that might be better done in a different language that communicates back to the core C code. It can be more modular, it can be shorter, it can be more maintainable. It can not have memory leaks. And then, since I'm short on time, here's some of everything else. A lot of this came out of either the community meeting that we, or a neighborhood meeting that we had a couple of weeks ago in Bangalore, some from the mailing list. These are some of the ideas, just a sampler of other things that we could do with 4.0. And this is the most important one down the bottom. Your favorite feature. This is a community event. I want to hear back from people, particularly people who have some familiarity with actually using the product instead of just developing for it. Because we develop it in this a lot about how people actually use it, right? Definitely get your vote in. I mean, we're still trying to figure out what the general shape of 4.0 is going to be. So, the more vocal you are, the better chance that not only will your feature get in as a separate feature, but will be fully integrated with all the other stuff we do. That it will actually become a core part of what 4.0 is. And that's it. Any questions?
So with heterogeneous networks, one model might be OpenStack and Open vSwitch and Neutron. Because with traffic shading, I'm not sure about global control, but I believe also that comes into play there. And basically creating these bridges which are interconnected by virtual Ethernet interfaces. And there's probably a lot that we can look at from them. And another thing in particular with OpenStack is Neutron doesn't know what the underlying implementation is. So you could use Open vSwitch or you could use Linux bridges, vanilla Linux bridges, and Neutron can still work on other bases.
Yep. So one open question on that is certainly not true today. By 2021, or let's say 2018, in between, is software-defined networking going to be something we can assume is present or not? I don't know.
Yeah, I mean, at least if you look at the big broader set of trends, I mean, that looks like a possibility,
Right.
a strong possibility.
So if it is, we can afford to rely on it. If it isn't,
I know, I mean, there have been efforts in the community also to kind of do some integration between software-defined networking and Gluster. I recently chanced upon a paper from WordPress where they did some early work on that. So there's scope. So Jeff, one question. So what would you like to be developed first in Gluster 4.0?
My own preference.
I actually think I agree.
Okay.
Because we're still going to have the problem that everything else we do is going to end up touching GlusterB.
Right.
The sooner we get get that into its new form and stabilized, the easier that's all gonna go.
That's like the interface where we need all our features to.
And some of the technical debt reduction should probably be high on the list for the same reason. If we're trying to add every feature to work with my favorite whipping voyage ball gen, the way it is now, and then we have to redo it,
Yeah.
it's just kind of dumb.
So one thing I was surprised at in seeing the slides was, I mentioned that Python, which could be, a big win for us to be implementing some of it in Python.
Certainly parts of it. I mean, I already have an infrastructure for manipulating raw files in Python, which Caleb and I developed as part of GlusterFS. And it's actually in our tree now. I forget exactly what it wrote along with, but I found a way to sneak it in there. So it's already there. I mean, if you want to do complex raw file manipulations, the tools are there.
The problem with that is it's not very well surfaced. By surfaced, I mean it's not well documented, it's not very obvious to people. If it was documented, well-known use cases of it, people would probably pick it up and use it more. But as we see, people talk about it and you pipe up and say, oh, it exists, and that's the only time we ever hear about it. So,
Right, I think we also have a page in admin guide for that. I think it's called filtered.
okay,
Is it called filter translators? Or,
Maybe.
yeah, something like that.
so the like the
Yeah,
admin
well, I
guide
mean,
from
neither the
4.4
new way or the
or-
old way is documented. I mean, is there any documentation for how Volgen works now? Don't think
So
so.
well, that'll be a problem.
Well, I mean, part of the problem is that you have to actually know how a piece of our core code works
Yeah.
to do stuff. I mean, we should be cutting that down to an absolute minimum. And we have translators, awesome. I mean, they let you write the I/O path code, link it separately, distribute it separately, whatever. But then to actually use it in a real way, we have no way to configure it, to set options for it, unless you go in and modify Gluster. So we need to sort of close that loop and say, not only can you write the I/O path code, but you include these other pieces, and voila, a fully self-contained new feature
Yeah,
that the rest of Gluster, core Gluster, never knew about, never needs to know about, but it still works. And when it's installed, you see new CLI options, et cetera. Who wants coffee?
So right outside to the right is the coffee area. There's coffee, there's fruit, there's pastries. They're just for us. So please go out and enjoy it.